Hello everyone, welcome back. This is Engineer Hussein Mwasabi. Alright, so this is a continuation of our NQNS Physics exam revision. So before we begin, don't forget to like, subscribe, and hit the notification bell icon. Alright, before we begin, let me just change my color to red. Okay, so the question reads to say that a projectile is shot from the edge of the building top, which is 125 meters above the ground level with an initial speed of 65 meters per second at an angle of 37 degrees with the horizontal as shown in the figure, this diagram, as you can see. All right, so determine the time taken by the projectile to hit point P at the ground, this point. Okay, so all right. Okay, let's collect data. We know that the height is 125 meters. That is from the ground to the top of the building. Not only that, we know that the initial speed, so I'll say V naught, is 65 meters per second, and this is at an angle of 37 degrees. Okay, with the horizontal, that is. All right, so other than that, let's take some assumptions. So let's assume the following. Our assumption should highlight the X and the Y. So in the X-axis, assuming that acceleration in the X is 0 meters per second squared, and the acceleration in the Y is equivalent to the gravity. And now in the Y, the projectile is going downwards. So if we take a reference or a dead term as this, positive, negative, like that, then this will be negative G. So this will be minus 9.8 meters per second squared. That will be the gravity in the Y, that as our acceleration. Then change in distance in the X. Okay, so let's look at the change in displacement of the distance in the X. So we know it's initial minus final. All right, so initial minus final, for the X-axis, we don't know the change in displacement or distance, because this is equivalent to the range, and we don't know the range value. We haven't been given in question, so it's 0. Then the change in the y-axis, in the height, difference in height, from, so initial minus final. So the initial is 0, the point, and the final is what you get when you reach the top. So initial is 0, because the ground level, you literally have 0 value, minus the final, which is the height of 125, so minus 125. This should give us minus 125 meters. All right, what else can we collect? Let us also find so we have the initial speed there, but as you can see, it's at an angle. So let us resolve it into its X and Y component. So let's look for the initial speeds component in the X. So resolving this would be 65 cos 37 degrees, which will give us 51.91130.813, which is basically rounded off to 51.91 meters per second. Then let's also find the initial velocity, or speed rather, in the Y, which would be 65 sine 37 degrees. And this will give us 39.1179765, which will be V initial sub Y, to be equivalent to 39.12 meters per second. All right, so if at all you find challenges resolving any vector into its components. I recommend you watch one of my videos where I did explain how to resolve a given vector into its x and y component. All right, so after that, we can also try and see if we have the velocity. That is, let me say the velocity before it reaches the ground. So let's just say Vx before it reaches the ground is Vx, we don't know. What of in the y? Vy, we also don't know that. So the velocity before it reaches the ground in the y, which is the final, or rather say. And the time in the x, we don't know. The time in the y, we also don't know. Okay, so let us now try and solve the first question. It says the time taken for the projectile to hit point P at the ground level. All right, so to hit point P at the ground level. So I'm going to use the formula for displacement, but rather we'll use for the y-axis because that's where we have enough information. So it's going to be the change in y being equal to v, the initial speed t, plus half at squared from x is equal to ut plus half at squared. You can recall from three motions that we have. So delta y is found to be minus that. So minus 125 is equal to v naught in the y. So the initial speed in the y is 39.12. Then we don't know the time, so we leave it as t. Then plus half g. The acceleration in the y is minus 9.81. Then we say t squared. This would be minus 125 minus 125 is equal to 39.12 t minus 4.91 t squared. This can also be written as 4.91 t squared minus 39.12 t minus 125 is equal to what? 0. This equation can be solved using a quadratic formula. So if we use our quadratic formula where we say x is equal to negative b plus or minus root of b squared minus 4lc over 2a, in our case where x now will become t. Now a is equivalent to 4.91, b is equivalent to negative 39.12, and c is equivalent to negative 125. Now let me just fast forward a bit. I will not put in the values, rather you can do that on your own. I just use my calculator. Okay, so using my calculator, just erase this part here to have some space. Okay, so if I use my calculator, what I will have is all right, so I'm having my time 1 to be equivalent to 10.41240,548. Rounding this off, time 1 is equal to 10.41. Then time 2 is giving me negative 2.444992036. Therefore, time 2 is equal to negative 2.44 seconds. Now, I'm not supposed to get a negative time value, rather, I mean the positive. Therefore, the time it takes to reach point P is equivalent to 10.41 seconds. And that is the time it takes for the projectile to reach point P. Now, we have been also asked to determine the range x of the projectile measured from the base of the building as shown. So this is the range that we're looking for, the x value. So we don't know the range currently, but we can find it. Okay, so we now have enough space. So to find the range, the range is acting in the x, so we're going to use the values of the x component. We know that the change in the x is equal to the initial speed in the xt plus half a in the xt squared. Now acceleration in the x, we know there is no acceleration, so it's 0 meters per second squared. So the range, which is delta x, will just be the velocity in the x times the time it takes to reach that particular distance where the range is. So this will be, because this side just end up having a 0, so the range, which is delta x, is equal to the x component of the initial speed, which is what we found as 51.91, then multiplied by the time it takes to move from to occupy the range value, which is reaching point P, which is 10.41. And then if we punch this on our calculator, we'll get a value of 540.3831 meters. Therefore, the range, which is delta x, which is the range, which is x in this case, is equal to 540.38 meters. And that is our range value. Now let us determine the magnitude of the velocity just before the particle reaches the ground. So what is the size of the velocity of the particle just before it reaches the ground? So firstly, we determine its components. Let's start with that in the x. So the component in the x is equivalent to v, the initial velocity in the x, plus a acceleration in the x, t. So the velocity just before it reaches the ground is equal to, because the acceleration, we know that acceleration in the x is equal to 0, so this will just be cancelled and will just remain with velocity, initial velocity in the x. So this basically just gives us the initial component we have, which is 51.91, and this will be meters per second. So after that, we need now to find the velocity component in the y, and that would be the initial velocity in the y plus the acceleration in the y times the time. So the velocity in the y is equal to the initial component in the y, which is 39.12 plus the acceleration in the y, which is equivalent to the gravity, so minus 9.81, times the time which it took to reach point P, which is 10.41. Computing this, we get the velocity in the y to be equivalent to, should be minus 63.0021. Basically, that will give us a minus 63.00 meters per second. So the velocity just before reaching the ground as the components, which is 51.91, that is in the I, minus 63.00 in the J. Having the components, we can determine the magnitude of this velocity. So this will be 51.91 squared plus minus 63.00 squared. And the magnitude of this velocity will be equivalent to 81.631171113. Therefore, the magnitude of the velocity rounded off to 2 decimal places will be 81.63 meters per second. So this is the velocity of the particle just before it reaches the ground. Now, having solved this, we can now determine the angle that we have here, which is below the horizontal made by the velocity vector. So all we have to do is determine the angle of this same velocity before it reaches the ground. So we say theta, this is for number 4, is equal to tan inverse of j over the I component. So it will be 63 divided by 51.91. Theta will be equivalent to, this would be 50.51 25607.8 degrees. Other people can also just leave the answer here, and most people will just mark you if you specify that this is below the horizontal. But looking at the position of this, you can always change that. That is if you want, and follow the quadrant in which it falls in. But I'll just leave it here and say theta is equal to 50.51 degrees, and this is below the horizontal. Because if you graph the components that you have here, you'll find that it's below the horizontal. So that's how you find theta. Now saying determine the maximum height reached by the projectile from the top of the building. Okay, so determining the maximum height, we always use one simple formula. So we say height max is equal to the initial speed, which is the velocity that is in the y. So when I say in the y, let me just say the initial speed. So we're getting the component in the y, sine theta, over 2 times the gravity, which is just the initial speed's component in the y divided by 2 times the gravity. And this gives you h max being equal to 65 times sine 37 divided by 2 times 9.81. Alright, so let's erase this. If you compute this, you have h max to be equivalent to 1529.5921 over 19.6. Then h max is equal to, if you compute this, you get 78.04 meters. And this will be your max height. Alright, so if you have questions, you can reach me on WhatsApp on the line 077 149 5252. Remember, slow progress is better than no progress. And let's strategize before becoming statistic. Let's try and push for that A plus.